Okay, welcome to 8C. What we're going to do here is we're going to talk about tidal patterns and the two theories that help us explain tides. One of them is called the equilibrium theory, and this is going to talk about universal physics laws that actually apply to this water-covered planet. So we're going to talk about how water moves, we'll talk about densities, and we'll actually try to explain all the tides based on those factors. Second way is what's called the dynamic theory, and this one actually talks about how it really works, and this takes into consideration everything we can throw at the whole idea. How much water moves, what water is, water density, water temperature, shape of the land, depth of the ocean, salinities, everything we can probably take, but we actually do find out some of the tides don't even work with these two theories. Declination of the sun and the moon. We actually find out that the sun is and the earth are traveling, or the earth is traveling around the sun. It does so with its axis tilted 23.5 degrees from straight up and down. So what this does is it actually makes the equator sometimes tilted higher than normal, and the sun's rays come in, hitting the Tropic of Capricorn. And then 6 months later, when we're actually tilted away or toward the sun, because the sun's still over in this direction, we get what's called the Tropic of Cancer getting the most direct rays. The Arctic Circle is actually getting 24 hours of light. Antarctic Circle down here, 24 hours of darkness. And the Tropic of Cancer or Capricorn is actually not in the picture. Tropic of Capricorn is getting the light's most direct rays. The Arctic Circle, 24 hours of darkness. The Antarctic Circle, 24 hours of light. These are 23.5 degrees because they're actually this 23.5 degree Earth, and the Arctic and the Antarctic circles are 23.5 degrees away from 90, so they're 66.5 degrees south and north. And then the last thing is, or another thing on here is the moon is tilted at 25.5 degrees from the sun Earth, so that actually makes a net 5-degree tilt. Because of that 5-degree tilt, when the sun Earth moon alignment is like this should be a lunar eclipse, except that it's actually too low. On this side it's too high, and only when the sun, the earth, and the moon all align in a node, in other words you can draw a straight line through here, and that's only when it crosses the Earth's orbit there or crosses the Earth's orbit there. So if we have a new moon right there and a full moon right there, we will either get what's called a solar eclipse, the moon blocking the sun, or we'll get a lunar eclipse where the Earth blocks the Earth. And I'm going to try to show that to you with this one. So I'm going to spend a little bit more time. This slide really does not deal with tides. It's going to talk about the equal AVI and also the node explanation for solar eclipse. Then I'll actually show you, actually why don't I do this first. This is a shock wave. Again, it won't work on an apple. This is the eclipse that's actually going to start. Can I stop this? I can't stop it. This is going to be an eclipse on August 21st, 2017, and you can see this little yellow line, and as long as you're in that little yellow line, you get to see a total eclipse. Inside this purple line, you get to see most of a total eclipse, and as we move out, there's 80% blocked and 60%. We're located about right here, and you can see we're going to have somewhere between 85 and 87% of the sun blocked out. If you want to see it, you got to actually move to this little yellow line, and I'm hoping I'm out here somewhere in Wyoming, Nebraska, maybe even Stanley, Idaho, because I think there's going to be less rain and clouds. August is hurricane season. I think the east coast of the United States may actually be pretty stormy. That should have closed. Okay, so let's go back into here. Second thing is how a solar eclipse would appear. This is a site called Time and Date. That last one was Shadow and Substance. And let's push play, and I'm just going to drag this. You can see the moon and the sun having the same about apparent size, and the moon can actually move right in front. That one, the moon's a little bit bigger than the sun. You can see that the moon's circle is a little bigger. That actually means that the sun is a little farther away, and we'll talk about that in D, I think. Either the sun's a little farther away than normal, actually the earth is a little farther, or the moon is a little farther in its orbit, and then it moves off. That's the eclipse. This is the eclipse that can cause so much blindness because our eyes get larger and larger as the sky gets darker and darker, and then right there the corona lights up, and it would look a lot brighter than that. And it can actually cause so much light going through the aperture, the pupil of your eye, that you can actually damage your retina. So that's the way that one looks. How would a lunar eclipse look? Same thing, timeanddate.com. And I'm going to, that looks like the sun. Did I put the sun on there twice? Let me do this one. And eclipses. And let's look at this one. Is that the one I want? This one. Same one. Okay, so what I'm going to do here is I'm going to take the moon, and you can see it moving in our shadow. This is a penumbral eclipse. It doesn't move into the umbra, the darker part of the shadow. I could have swore this was a much better. So basically, this is the area that's going to see it. So we will see it also, but it'll be pretty early in the morning in order to see that eclipse. Whoops. Okay, I do want to show you these two. So I'm going to stop this. I'm going to go to my Google Drive, and we're going to show the equal plane. Equal plane basically says that, stop it, the plane of the moon's orbit around the Earth and the Earth around the sun are on the same plane. So every time we have a new moon, we're going to block out the sun. Every time we have a full moon, we'll block out the moon. We're looking toward the sun, so we're just going to see this. And you can see right there, we move moon in front of the sun, solar eclipse. Comes around again, solar eclipse. Comes around again, solar eclipse. Comes around again, solar eclipse. And we would actually have multiple solar eclipses. It doesn't show you the lunar eclipse, but the lunar eclipse would happen out here when the moon is farthest away. I don't know if you can see that because that's probably where my face is. It happens when the moon is actually farthest away. So the sun's rays come in, Earth blocks it, the moon moves into our shadow, and we would have these things every 2 weeks, and they would not be special. The node explanation, and these files are both on Fusion. You can download it and do these also. The node explanation is just when this red line, in other words, that's where the moon would be, aligned with the Earth, aligned with the sun. When this red line points to the moon, the Earth, and the sun, so it should actually be like right there. When that moon is on that node, we would get a solar eclipse, and when it's on that node, we would get a lunar eclipse, but that only happens when that red line is pointed toward the sun. So let me show you. It's getting closer and closer. And there it points towards the sun, and there is the moon blocking. And the next time it goes through, it's too high because it's not on the node. Next time it's a little closer to the node, too high. And the next time, too low. And actually even lower, but coming up and too low. And that's the way the nodal explanation. We don't get but maybe 2 eclipses as we come around. Okay, so did I close it? I closed it. Let's go to this one. Unequal tidal range. The moon, because of this 28.5 degree or 5 degree change, actually moves this 40%. Excuse me, the 60% for the moon. This is the 40% for the sun. Actually moves this thing up and down. And when we actually get this line and this line going, we get an eclipse. And because of that, we get the highest tides about twice a year, or solar eclipse about twice a year. Tidal bulge. Remember the tidal bulge of the Earth points in different directions. It actually leads the moon. It's a little bit ahead of the moon. Here's the moon, and there's the tidal offset. And because of that, the Earth rotates underneath it, and it actually slows the Earth down because it runs into this. And it also, while speeding up the moon's orbital speed, because the moon's trying to torque itself up, the Earth is trying to torque itself back, and we're slowing down our rotation, making our days longer, and we're actually speeding up the moon, which is causing the moon to move farther and farther and farther away from us. We also have what are called perigee and apogee. Perigee is when we actually get the moon farthest away from the Earth, and if we had this, if this was toward the sun, we'd actually find that the moon would not pull quite the 60%. The sun could actually be doing the same thing. Perihelion, if we're towards July, farthest away, not quite 40%, and we may only get 90% pull. Where this one, if it's actually closer, we'll get more than 60%, and the Earth is closer to the Sun, more than 40%, and we may get 110%. So we could even get larger highest high or lower lowest low. And this one, we may not get quite as high tides, or we won't get quite as low tides. This is perigee. There's apogee, and you can see the difference when we have a close moon or a far moon. Far moon, close moon. And this is the sun, perigee and apogee, where we actually get perigee when it's closest to the sun, or apogee where it's actually farther, and you can see the difference. If we get an eclipse with this moon and that sun, it'll actually last longer than if they're the same size. Or if we actually get this one and this one, it'll last longer. Just like if we get this moon and this sun, we may get what's called an annular eclipse, where the moon doesn't quite block out all the sun and there's a little bit of sun on the outside. And you can Google those. So the lunar tidal eclipse, this will actually make higher high tides, and the apogee lunar tidal force is lesser, and that'll make lower high tides. So everything that a spring tide does, or a neap tide, this doesn't do neap tides at all. Anything a spring tide does, so whether it be a new moon or a full moon, these will be higher than normal, highest tides, and these will be lowest tides. And there's the stop. Thank you much.